Welcome back to part 2 about diodes. Let's start with a review. So let's try to figure out which of the following diodes are on. Actually, stop your video right now and decide A through F, which diodes or LEDs are on. Okay, now we'll discuss your answers. So first of all, let's go through and check which ones are pointing the direction we'd expect them to even turn on and eliminate any ones we think are for sure not on. So current should flow this way through A, this way through CD, this way through B, this way through F, and this way through E. So I immediately see some issues with B, E, and F. So B, I see that current, if the diode was on, current would flow up through it, but the voltage supply has the positive facing up over here, so we would have current flowing this way. So therefore, B is not on. E and F, while E is pointing in the direction that we'd expect positive current flow to occur, F is in series and pointing in the opposite direction. So this is actually an impossible circuit for either LED to ever be on, because current has to flow either this way or that way. And in the case that it's flowing upwards, E can't be on. And in the case that current is flowing downwards, F can't be on. So these LEDs are not on. A is our standard basic circuit with a current limiting resistor, and we notice that A should be on as long as its forward voltage is below 5 volts. I see here it's an LED, so it will have a forward voltage below 5 volts and it should be on. Over here on the right, C and D, well, it depends on the forward voltage. So if the forward voltage is 2 for each of these LEDs, then they can actually turn on. If it's more like 3.5 volts, then you would need at least 7 volts over here to turn on both of those LEDs in series. So whether or not they're on depends on their forward voltage. Okay, let's move on to solving more complicated circuits with diodes. So the general method is a guess and check method for solving circuits with diodes. First, you should make an educated guess, like we just did in the previous slide, about which diodes are on. After you assume that those diodes are on or off, then you can solve the circuit mathematically and then check your answer. And if you get a mathematical impossibility, then try again. Your guess was not correct. So we're going to do a couple examples now to practice our educated guesses and kind of get a feel for how to work with these circuits. So here's the first example. Is the LED on? So when I look at this, I see, oh, 3 volts for the forward voltage, and we have 5 volts over here. So yeah, current can flow this way. Okay, I'm going to assume that LED is on. So let's look more closely at that case. So if we assume the LED is on, then we have our 5 volt supply over here, we have a resistor, and then we have forward voltage of 3 volts, and then one more resistor. Okay. So now we're going to check whether KVL and KCL hold. So if I make this ground over here, I know what the nodal voltage is both here and here, so I can calculate the current through that resistor. So we have 5 volts minus 3 volts over 300 ohms is the current through that resistor. And I'll call that I1, draw it here, I1. So that's 2 volts over 300 ohm, which is the same as 6.7 milliamps. Okay, so now for this other resistor here, we have one end at ground, the other end at this node up here with 3 volts. So we'll label this I2. I2 is equal to 3 volts over 200 ohm, which is equal to 15 milliamps. Okay, so let's go draw this on the picture up here. 6.7 milliamps, 15 milliamps. Okay, so using KCL, what does this current here have to be? Well, we actually have more current flowing out of the node right now. Here, 15 milliamps versus 6.7 in. So actually, this is pointing the wrong direction. It's going to be pointing this direction and be equal to 8.3 milliamps. Oops. So I just ran into a contradiction here, right? Because current can only flow downwards through that diode when it's on. But we just calculated a solution where it's flowing upwards. That means our assumption that the diode was on is wrong. So let's go back and repeat the problem, assuming the diode's off, now that we realized it must be off. So I will erase our work so we can get a fresh start. Okay. And we will start again fresh. So now we are assuming the diode is off. So the simplified circuit will look like this. I'm curious about this voltage right here. So when I look at this, I see a voltage divider. And so we'll take 200 ohms divided by the total resistance, which is 200 plus 500 plus 300 ohms, which is equal to 500 ohms there on the bottom. Times the 5 volts. And so that is equal to 2 volts. So this is equal to 2 volts. And 2 volts, if this node here is at 2 volts, that is less than the forward voltage. So the LED is not on and all the math checks out. So the LED is actually off in this situation. Let's look at one more example. When will diode 1 be on and when will diode 2 be on? So first of all, we need to know the forward voltage of both of these diodes. They don't have LED light emitting symbols on them. So we're going to assume these are just standard diodes with a forward voltage of 0.7 volts. So that means to turn them on, I'm going to expect that this has to be at least plus or minus 0.7 volts. If it's less than that, there's just not enough oomph. The diode won't let current flow. So I've eliminated the range of negative 0.7 to 0.7 volts. So both of these are off. Okay, what happens if I go above that 0.7 volts? Once I go above that, there should be enough voltage to turn on a diode pointing in the direction of positive current flow. So that would be this one right here. And then if I wanted to calculate the exact current through that diode, we'll just redraw the simplified circuit. And I'm actually going to simplify this again. So now we'll combine both of those resistors because we learned that that's an equivalent circuit. So combine them into one resistor, which is 2 kilo ohms. And then we'll replace the diode with a 0.7 volt voltage source. So now it should be easy for me to calculate what the current is through that diode. Similarly, if I want to turn on D2, it's pointing in the other direction. So that means I want a situation where current is flowing in the other direction. So I want current flowing this way. So that's going to be when V in is negative. And in that case, D1 will be off because it's pointing in the wrong direction. So the simplified circuit, so this is the case where D1 is on over here, by the way, that we just calculated, and it's when V in is greater than 0.7 volts. Okay, so now we're working on the case where D2 is on and D1 is off, we said. And so the simplified circuit's going to look like this. And again, we can rearrange everything. So we have a single resistor. This time it's got a resistance of 3 kilo ohms. And actually, I will replace that diode with a voltage source of 0.7. Okay, and now we should be able to also calculate the current in that case.